Okay, good. Well, let's take a look at, now that we're recording, let's take a look at istio.go and so how this works. I think part of what you were describing as having come together is an info interface or model or
a model. So this is our MeshSync representation of a mesh, or meshery operator representation of a mesh, and all the information that we need to know about any of the meshes. So it should be mesh agnostic, but if there is some information specific to a mesh, then we use some opaque data as well in there.
Got you. Okay. Yeah, and right now, or thus far, we're saying, hey, universally, every mesh should have a version number.
Yeah.
And as that, like as a specific example of how that is retrieved and the code that we use, the mechanism that we use to determine that is reflected in istio.go.
Yep.
And
so I would go to the sync.go file first. So sync.go defines your synchronizer and the processor methods, the interfaces. So by processor, it's basically the pipeline. Fingerprinting, I could change this to a fingerprinter or whatever so that it's more obvious. And then if you go to istio.go, that's where you're implementing this. So Istio is your struct, and then you have the synchronize method and you have the process method implemented in the same file.
To the extent that that it's a multi-cluster deployment where where you've got some control plane components in two different namespaces and two different clusters. Is this a hindrance to that if it's just one namespace, or would that just be a different processor?
I don't know yet. I mean, I honestly don't know how to handle multi-cluster yet, but I don't want to worry about it right now.
Sure.
So yeah, we'll have to go through more iterations when we start looking at the multi-cluster requirements, and then things could change. But at the end of the day, that's why we have the interface, the sync.go. So as long as you implement that interface, and whether you're using it for multi-cluster or not, it should be fine. It should be reusable across the code. So that's what I'm going for, because if you look at sync.go, there's nothing about Kubernetes in sync.go.
Right.
So it just says there's context weight groups and there's models.event. So there's no assumption that it's using Kubernetes or using one cluster.
Okay, gotcha. Which I guess brings up when we're talking about the kube config earlier and how that's used as part of, I think, when you instantiate a new client and start a new connection, the way that we have MeshSync overall designed today, is it capable of connecting to two different clusters at the same time?
Not right now, but it could be.
Okay. Okay. And then, so we go down, trying to look between. Did we look at, yeah, we did event info. Okay. Okay, so backend Istio.go. So this this start discovery is this is new, right?
Yeah. So this is the big hammer, the first lookup.
As when you step back and think about how that there will be a a linkerd.go and how it will like be across each of them, that like if we could, I mean, if they were all the same, we wouldn't have different ones, but they're not going to be, and so some of the mechanisms are going to be different. And but I guess what I'm trying to say is like when we look at how we've done Istio.go, does it make for a good template to do which begs which will be nice to, like if the answer is sort of yes or towards a yes, that works out well, because literally like, hey, we would, if there was something like a template that will help with uniformity and consistency in the other.
Yeah, I guess I understand your point. So the only templatized things or things that I can break out into modules is the processing pipeline on how things are passed through that, and that could be reused across different meshes. But there is going to be uh, some differences, and I wouldn't say start discovery is the same in Linkerd as it is in Istio. But the only thing I can say is when that process function is called. So there could be some templates there, but as of now, things are pretty abstracted. The synchronize starts the synchronizer, which passes the first discovery event to the process function. Process function is where the pipelining happens to fingerprint a mesh. So, I mean, your template essentially is process and synchronize. And how you implement it is, we can give some hints, or we can create a template which says this is the process. You do a discovery step, and then you call I dot process or whatever the process function. But I think that's all we can do.
And that's actually a good, that's kind of the answer that I was looking for, which is like there's quote a template in terms of like hey, that they will all or we would, each of them should have a start discovery, and what the contents of which may be radically different.
Yeah.
Ideally we would be shooting for, we would be using the biggest hammer first, or we would be looking for that universal or it's mandatory that it needs to fulfill the attributes inside the universal model, which starts with version number. And so we would expect most of the time that start discovery is first and foremost hunting out the version number. Nice. Yeah. And to your point, like, yeah, having having a processor as a distinct thing that executes, and at some point has sort of inherently the concept of tiers, or whether it has that concept or not, but that you're able to, you might have that logic somewhere else where you're saying,
Yeah. And I'll try to rename it better so that it's not just a generic process, like that doesn't uh, give out too much information. So I'll change the interface from whatever I'm calling it. I forgot what it's called, processor to fingerprinter. And yeah, it could have a process method within, or start pipeline or something like that.
Nice. Makes sense. So then, yeah, I guess if we take a look at this, is there, I'm trying to add what value I can here. Is there, do we need to be concerned with a timeout for and maybe that's not really the case here, that if you're, I guess, you're guaranteed that the Go client that we're using in this case, Istio, the Istio Go client, has an operation for retrieving the version. It has some of its own logic built in already, where if it can't invoke that, if it doesn't, retrieve a response. So speaking of, I guess, yeah, in this case, I mean, well, it's evident and somewhat obvious when I make this statement that we're relying on the Go client for, in part for like its own, it has some amount of discovery, if you will, built in, where we're handing it the cube config, and it itself is trying to identify the version of, an Istio that's deployed.
Yep. So it actually is kind of doing. So the way it works is it puts the pilot in proxy mode, and then invokes I say /status, some API, some URI to, towards that proxy, so localhost, whatever the port is, and then it shuts it down. So I mean, it stops proxying. So that's the mechanism they use in the Istio kernel code.
Nice.
In there. So I mean, that's the way they can query pilot. They don't have a public IP or a cluster IP that they use. Yeah, I mean, that's their method. There could be better methods to do it. And
no, yeah, but the thing, yeah, right. No, it's a beautiful design. I mean, yeah, hey, if there is a better method, we figured out at some point, we can move to that. But to move briskly and to rely upon, it's the important thing that, like, it's not just the fact that they've got, some decent mechanism coded up today. It's also very important the fact that there's some amount of commitment that they'll be sustaining that over time, and that as that changes, maybe that they do find something better, that it kind of doesn't matter. I mean, it matters, but there may be no code change for us, which is just a beautiful thing. This is great. By the way, Nitish, Shivam, thanks for jumping on. I know you jumped on right in the thick of this discussion, but given some of the work that you've been doing in the community, I figured well, Nitish is working on a core component of sort of the second generation of how it is that Meshry is going to stay in sync with Kubernetes and stay in sync with the service meshes that are deployed, understand particular details about each of those service meshes. And so this project MeshSync, very important for Meshry overall. And it'll have a number of, well, there's different facets of it that might end up being interesting to you. You might end up taking on a piece of it, if you will.
Yeah, sorry, I'm getting a call, so I'm just going to step away for a second.
Okay, got it. Okay, good. Shivam had a slow connection, so he ended up dropping halfway through my description. He's coming back.
Okay.
Moving along, under models, event.go. So we're defining event types. And talk aloud, if you would, about the different types of events you consider will come through.
So the discovery event is the first thing that we talked about, is the Istio version, the first step before we start fingerprinting. So I haven't thought about what those event types are going to be, but they will be part of the fingerprinting process. And maybe there's no other event types, but I just want to say that there's a discovery event and then there's all other events.
Yeah, no.
Right. There could be more specialized events that we start building, and I don't know. I mean,
yeah, no, it's a great capability to have. Yeah, maybe there's discovery, maybe there's an update or a change, like like existing object that you already knew about, but you're getting an update on it.
Yeah, so maybe you get an event from the API server or the shared informers, and you kind of massage that into this event type, and you send this over the channel and say, yeah, this was a
Nice.
Yeah, this was a update, or this was a change, or this was a delete event.
Okay. So Shivam, I think, is able to see what we're talking about, but can't hear us at the moment. So, yeah, the more to that, there was a question that I'd had earlier was, and I don't know. I don't know what the answer here is. And I don't know if maybe if the answer is yes, and we're able to do this, maybe that's actually bad. I don't know. And that is, for a given, let's say that, we discover a Linkerd deployment, and in discovering it, we say, okay, well, great. That's there's either some combination of attributes, a composite, or whatever. I forget what we were using before, but that in which you derive literally the fingerprint of that specific deployment. So you're able to say, yeah, that's Linkerd deployment, with this identifier, and it's got a unique identifier. And when we figure out that there's another Linkerd deployment on same cluster, different cluster, whatever, that we're also then able to assign this unique identifier. And my point is like, if you carry that through every object that you're synchronizing, there can be a lot of benefit to having a unique ID for each and every object, to be able to say, well, yeah, this is the same Istio deployment overall, but that is a new instance of pilot. Turns out that it was rebooted or reincarnated, or that one's been upgraded, or
no, I get what you're saying. We need a unique identifier for the events as well.
Yeah, a unique ID about the event, or I think having a unique identifier can facilitate an update event, like because in some respects, if we know that we have a Linkerd environment, and we're getting update events about changes to it, how we correlate between, how we know which Linkerd that we're tracking to update becomes
So when I start the control process, it's gonna generate a UID, give it back to wherever you want to store it. Maybe there's a in-memory store, there's Redis or whatever, and then Yeah, I mean, yeah, you're right, and those things are going to come organically. Uh, so so yes, that's a good point. I'll keep that in the backlog, but yeah, you're definitely right. Because right now I'm just focusing on one single mesh and there's only one single instance.
Sure.
When I start adding more instances, that'll start becoming clear that, oh, how do I differentiate one event from another? Because another thing with the events is I want to make it a broadcast event so that different components can parse that event. But but yeah, it'll that part of it is going to be pretty organic and see how it grows out. But
Fine. Yeah, a potential negative to arriving at that
mhm,
is, well, or is in these, well, I don't know if they're edge cases, but in these scenarios where, well, no, you actually have, or I think it comes down to what is the composite set of attributes that um, makes up a given UUID or a given,
mhm,
now the word that keeps coming to mind is like that makes up a given fingerprint of that actual object. And if the object is this like individual objects that may be somewhat hard and fast, that you're saying, okay, so you're telling me there's an Envoy proxy that's sidecarred to this service, whatever. Great.
mhm,
Well, I can tell you in pretty hard, in pretty definitive, definite terms, that Envoy proxy is UUI, is this fingerprint, UUID such and such. And yep, that's the same container that's been there. It has
mhm,
not had a, like, you can sort of, from the time that we understood that it was deployed, or maybe we deployed it fine.
mhm.
Um, and, and then, but
That,
when
that-
we,
yeah, that's why I meant like a Redis-like database, some in-memory DB or RAMDB, where I'm gonna stick in the UID and then all the information relevant to that. So the UID could have a set of sidecar UIDs, a list of sidecar UIDs as one of its fields. So all the information will be in Redis, so that if we do crash and come back up, there's going to be a warm start where it loads up everything and it starts the controller. So maybe an event comes from a sidecar. Uh, there's a lookup mechanism where keys are related, where it says that, oh, this is what I have, what are the UIDs that are correlated to that.
very good. And um, that it actually could be bad. Potentially, having a model like that could get us into some hiccups where if we're trying to create and identify a fingerprint for um, a logical construct that we're tracking, and I guess by this, an example is, here's the fingerprint for that Linkerd deployment. And the deployment means like, oh, okay, so it's all of the proxies, it's all the control plane objects.
Mhm.
And that would be something that that logical identifier for a given deployment
Mhm.
is the reason that I'm thinking I mean, that's a nice thing to be able to say, like, hey, and as a user, when you go over and you want to look at, you know, um, I've got 3 Linkerd deployments. I want to look at deployment number 2. Um, from a user perspective, that's a great control point, like to be able to filter your view and affect certain things.
Mhm.
Um, but
Do you think Spiffy is a good way to identify things?
I do, yeah, yeah. Um, Yeah, because it's actually that judo move that you did with the Istio Go client, where you're
Mhm.
looking, where we're finding the version and like we're not doing anything. We're just,
Right, right.
like, and it's the same thing with the Stiffy. It's like, look, like, yeah, somebody else is going through the complexity of, defining what a unique idea is, and then
Mhm.
assigning those, creating those, rotating those, blah, 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 and all that stuff.
Right.
And then moreover, if we're using that natively later on, when we do have a use case for, terminating access to, I don't know, whatever that, some use case that it'll be the same language. We won't have to translate between.
मैं फोन चल रहा हूँ बराबर 2 मिनट
Yeah.
And so, and the thing I was trying to get to is to say where we might run into an issue is, I think Istio is a good example where we say, okay, well, there's 3 Istio deployments. By the way, one of them is this multi-cluster deployment in which it actually, the composite set of identifiers that we use to fingerprint and say this is a deployment might get in our way because the deployment model is so flexible that that we end up saying that hey, this is an Istio, this is one Istio deployment when it turns out it's, or we end up saying there's 3 Istio deployments when it turns out there's just one. And that might have less to do with the fact that we use an identifier, a unique identifier, a fingerprint, and more to do with the fact that the question of what set of composite pieces of metadata are we using to create it?
Yeah.
Anyway, yeah, good. A lot of the things that I'm bringing up are. So in no way, any of the things that I'm bringing up are ever pointing out like, hey, where what we have right now is crap. That's not,
No.
Yeah, and so when I bring up stuff about, I don't know, like multi-Kubernetes cluster and things, it's a perfect response that you have like, well, I don't know. I mean, we'll get to that when we get to, or like, good. And I'm not bringing it up to like make it more, or I'm bringing it up to try to, yeah.
No, I think the best thing to do there, and since these are thoughts that are in your head and you know what those requirements are, maybe you can build a requirement table in Google Docs, something like a may, must not kind of matrix.
Totally.
And once that's in there, then I can start thinking of how we start making it agnostic. It doesn't have to be Kubernetes. It doesn't have to be one cluster specific. It's concerned with how things are deployed from either Meshery or something to identify an existing control plane. So yeah. I mean, once the requirements are there, I think it'll be a lot easier. So if that's something you want to take on and just capture the larger requirements, like you're saying, I think we can go over that, and I can refine the design, and maybe there's most of this is throwaway and I could start all over again, but that's not.
Yeah.
No, I know what you're saying, but sometimes it is the case, right? You write one to throw away, but it gives you an idea. So that's not a bad thing. That's part of software design. So
hey, what's right on. What is what's IOTA?
it's a 0, so it's a commonly used representation of 0 when you define constants or when you define enumerators.
Okay, cool.
Yeah, if you hover over it, it's gonna say 0.
Fine, that's fine. Okay. String returns it. Nice. Okay. I don't know if I've got any other. Yeah, the processor. And to your point, yeah, I know. I know. It's. I got to tell you how. I mean, this is in part why I was hoping for Kanishkar or a couple others to start, because it pains me when we're having this conversation and we don't have some things written down, because you're doing a fantastic job of choosing some terminology that makes a lot of sense. Like processor is just as good as fingerprinter, or like maybe fingerprinter, like you were saying, is a more descriptive thing. Like it's a specific term that is gonna, once someone has understood the concept of it, like there's no other way to talk about it other than using that term, because there's so much behind the term that, but anyway, my point is like, hey, if some of this stuff was written down, it would also help with well, not, you know, with the, or I'm not finishing my sentence because what I'm not saying, hey, of some of those requirements and some of those visions or the goals or what have you that are written down, that doesn't mean that they need to dictate what those things are called per se, but rather as we talk through it, whatever it ends up getting called it's so helpful to when it's consistent, when it reinforces the, oh yeah, that's the thing, that's the. Well, so hey, Shivam, have you been able to hear us for at least a little bit here?
Hello?
Hey.
Hello.
Yeah, we can. Good. I appreciate you jumping on. It's I know you jumped right into the middle of it, which is tough. Can you hear me?
Yeah, I think he can. He said he can.
Okay. Oh, nice. So Shivam, it's very good of you to jump on. Hopefully I know most of this is completely out of context. But we'll spend some time to give you some context. This is quite an important component for Meshery, and so is a great place for you to potentially make your mark on the project. So it's just getting started, and eventually Nitish will be at a point by which a lot of the structure to this is here, and he'll have, you know, there'll be one or two of the first examples of how we're going to discover and synchronize a service mesh that you might be able to do, you know, do some of the same with a different mesh. So fair enough. So Nitish, I guess so I'll take my action item. I need to go figure out how to drop some things. Honestly,
Okay.
like, I don't know, one of those things is like dropping. There's like 2 KubeCon talks that I'm supposed to give. Like one of them is just like dropping that talk and writing down that. I mean, like it's in a good way. In a good way, you know, it's hard to, I don't know. I mean, I don't, let me stop.